main function section. The compulsory or mandatory function in any C program is the main function. So without main, your program cannot work. Any C program you write or any multi-function program you write with more than one function in your program, which is the mandatory function in your program is it is main function. So your program execution starts from the main function. If you are not writing the main function, then there is no starting point of execution of your program. So your program cannot work at all. It will not run at all. And who is going to make a call to the main function? So someone has to call the function so that that function gets executed. So who is taking the responsibility of calling the main function? It is the operating system. So remember, operating system is responsible for controlling and coordinating the activities in a computer, or it makes the computer operational. So here operating system is responsible for invoking or calling the main function. So main is being called by operating system. So other user defined functions what you are going to write in a C program, those will be called by your functions in the program. It may be the main function which invokes the other functions, or one user defined function can in turn make a call to another user defined function. So what are those, or how to do all those operations, that we'll discuss in detail once we go to user defined functions topic. Okay. So just remember, with respect to main function, these points: main, it is a mandatory function in any C program. Program execution starts from main function. It marks the starting point of execution, and operating system is going to invoke the main function. So these points you need to remember. And one more point is, uh, in a C program, there should be only one main function. You cannot have multiple main functions in a program. So if it were to be multiple functions, then it will be like there will be ambiguity in finding the starting point of execution. So that's why duplicate main functions are not supported in a C program. There should be mandatory main function, and it should be just one main function in a C program. So this is one more important point you need to remember. Coming to the sections you find in the main function, or it may be any function, any user defined function you write, or main function which is coded by the programmer. It consists of two parts. One is called as the declaration part, other is called as the executable part. The declaration part means whatever the variables you're going to use in your program to perform the operation, those variables you're going to declare. You know the reason for declaring a variable, and also we have discussed the syntax of declaring a variable. So that declaration statements you're going to write at the beginning of the function. So it may be a main function or any user defined function. Within the particular function, first we are going to have the declarations of the variable. Okay, through the declaration statement we'll be declaring all the variables which we'll be using in our program to perform the operations. So that is about the declaration part. Coming to the executable part. So in executable part, whatever the statements, say for example, you want to read some data, you want to just print the data onto the screen, or you want to read two integers and compute the sum of two integers, and you want to print the result onto the screen. So other computation statements, it may be a input statement, output statement, or some processing statement. So all those statements you are going to write in the executable part. That is, after declaration of the variables, you're going to write the logic of your program. Okay, to solve the particular problem, you're going to write the, or you're going to implement the logic using C syntax. So that is about the executable part. That means those statements will be executed during runtime or execution time. That is the meaning of executable part. So remember, main function consists of two parts: declaration part and executable part, that you can recall with the structure of the C program, what we had discussed in the previous class. These are the two parts you find in any function. Here we are discussing with respect to main function. Okay, that's what I've listed here. Declaration part declares all the variables used in the executable part. Any C program contains at least one executable statement. So you're going to write a program to perform some operation. Maybe just a display operation you want to perform, something you want to display onto the screen. Right? Say hello or good morning you want to print onto the screen. At least one executable statement must be there in any C program. If you don't have any statement, that is also fine. Your program will work fine. You can simply write int main open close parenthesis, open close flower brace you can give, and you can execute your program. but it will not produce any output since you have not written any executable statement in the main function. So see that you are writing a program to perform some specific task. So it may be just the output operation you want to display some data onto the screen, or you want to perform some operation and the result of operation you want to print onto the screen. So this is the one more point, that is any C program contains at least one executable statement. So all the statements in the declaration and executable part ends with semicolon. This is one of the rule in C programming language. Each statement must be terminated with semicolon. So whether it is a declaration statement you are writing, or it may be an input statement, or it may be an output statement, or some computation statement, each statement in C should be terminated by semicolon. So that indicates the end of C statement. So once you write a statement, say for example, I want to perform sum of two numbers and I want to store the result of addition in another variable, a third variable. Sum is equal to a plus b, all right. Followed by that, I have to give semicolon. So that indicates end of that statement. So C equals a plus b, or sum equals a plus b. That is the computation statement. It is terminated with semicolon. That indicates end of the statement. Okay. So coming to the examples, we consider a simple main function. Hash include stdio.h, the header file we have included. Int main, this is the main function header. So the first line, we are going to call it as the function header. Okay, this is how we are going to write the function header. We'll specify the return type of the function. In this example, I've given the return type as int, and the name of the function is main. As I already told, each letter in this function, it must be in lower case. So it is a predefined identifier, that is main. It is actually user defined function. So the main function is a special user defined function. The name of the this function must be main only. You cannot give any other name. This, since it marks the starting point of execution. Okay. See, and to indicate the block, here we need to make use of pair of flower brace. To indicate this as a function, you'll be using open close common parenthesis. Okay. First is the declaration part. This is the declaration part I have given. I have declared an integer variable a, and I have assigned value 50 to that variable. So a is an integer variable which occupies some memory space. It occupies actually 2 bytes of memory space, and in that 2 byte of memory space, 50 is the integer data stored. Okay. Then I'm trying to print the value of a using printf function. We are using the built-in function printf. Within common parenthesis, we are going to specify this format. Within double quote, we are giving a equals percentage d comma a. Whatever the value held in a, that gets printed onto the screen. So what is the format of the output? It prints this string a equals, followed by that it prints the value 50. So percentage d, it is called as the format specifier. For printing an integer value onto the screen, you will be using the format specifier percentage d, where d stands for decimal integer. So if this percentage d will be replaced with the value held in the variable. So here a is the variable we have given in the variable list in the printf function. So that value gets printed onto the screen. Okay. Finally, we'll be giving return 0 and close the main function. Okay. One small program you are seeing with mandatory function, that is the main function. It's a single function program we have written, where we have declared an integer variable, we have printed and we have initialized that variable with value 50, and we have printed the value of a onto the screen. And just observe the return type of the function is int. Okay. And the last statement we have given before ending the main function, before the closing flower brace, the last statement we have given is return 0. So if the return type is int, okay, for the main function, you have to give return 0. So what this return 0 will do is, it will terminate the program. So once return 0 is executed, the program gets terminated, and this integer 0 what we are sending, that will be received by the operating system. So it in 0 indicates the successful termination of the program. So once return 0 is executed, program gets terminated, and the status code, this is called as the status code, which is 0, indicating it is successful termination of the program. So if you are giving non-zero value, that indicates program has been terminated with some problem, or it may be unsuccessful termination of the program. So usually the last statement in the main function will write it is return 0. 0 is the value status code we are going to pass to the return statement. Okay, and we say int and return, they are actually keywords. Okay, so predefined words or keywords. So what actually mean by keyword and what are the keywords supported in C, all those we'll be discussing in later classes. For the time being, in this example program, you can identify the keywords. Int is one of the keywords supported in C. Return, the last statement in the main function, this return is also a keyword. Okay, return space we have given 0. If you want to give within parenthesis, within common parenthesis, return 0, that is also fine. So there are different ways of writing return instruction that we'll be discussing with more and more example programs. Okay, hope this program is clear. Header file is in, we can observe the link section is written here. Hash include stdio.h is the statement, preprocessor statement we have written. The main function header we have given is int space main open close common parenthesis, and within this pair of flower brace we have written three statements. First statement is called as the declaration statement, where we have declared the integer variable a and we have assigned value 50 to it. This is compile time initialization for the variable a. So during compile time itself, the memory will be allocated for the variable as well as it is initialized with the value 50. And then in the executable part, we are seeing two statements, printf a equals percentage d comma a, and the last instruction is return 0. So return 0 is to terminate the program. The status code 0 will be received by the operating system, indicating successful termination of the program. Okay. By default, the return type of any function in C, it is integer. So if you don't specify the return type for main function, if you simply give main open close common parenthesis, so in that case, it is compiler interprets that return type as integer type. So the default return type for any function, it may be the main function or any of your user defined function. If you don't specify the return type of a function, then it is treated as by default integer data type. Okay, that means it assumes the function is going to return an integer value. So just observe in the previous example, return 0 I have given. 0 is what type of data? It is an integer data. So since this main function is returning an integer data to the operating system, return type of the function is given as int. Okay, if any of the user defined function you are having in your program, if that function is returning a floating point value, okay, in that case we are going to specify the return type of the function as float. So depending on what value the function is going to return, okay, to the calling function. So here who is going to call main? It is operating system. So return 0, it returns the control to the operating system with the status code 0, indicating successful termination. So user defined functions are invoked by other functions in the program. So whichever function which calls an user defined function, to that function we can return any type of value. So if we are returning a floating point value, then we are going to specify the return type of the function as float. So depending on what value is being returned by a function to the calling function, we are going to specify the return type of the function. So if you don't specify the return type, what is the default return type considered? It is integer type. Okay. So this is one more point you need to remember with respect to the return type of any function. It need not be a main function. Coming to the main function header. So there are different forms of main function you can write. Okay. And in throughout this course, we'll not be passing any argument to the main function. What do you mean by argument and all? We'll discuss later. So this is the different forms of main function header. So the first statement, int main open close common parenthesis, what you write. So that can be written in different ways. Okay, that is that statement we are going to call it as function header. Okay, int main open close parenthesis, or you can write int main of void, or main. So if you are using any of these forms, just see in first two headers I've given the explicitly I've given the return type of the function int space main open close common parenthesis. If you don't specify anything within pair of common parentheses, then it is treated as void. Void is also a keyword. That means the function is not receiving any parameter or argument, we can say. Okay, if it is so, it is the data type we are using is void. Okay, so just see the first statement, int main open close common parenthesis without specifying void. If you don't specify also, it is treated as void type, meaning the function main is not receiving any parameter or any argument. So the second statement you can observe, return type is given, it is integer, name of the function is main. Within a pair of common parentheses, we have specified the data type as void. Both are same. So these four are actually equivalent function headers we have written. Okay. Explicitly, if you want to give the type as void, you can give, or you can just give it blank. Okay. Just you can specify open and closing common parentheses. Coming to the third form, main of void I've given. I have not specified the return type of the function. As I told, by default it is treated as integer return type. You can give like this also, the main function header, or simply you can give main open close common parenthesis. So what this indicates, the function main is not receiving any argument, a parameter, and it is not returning in, and the return type is integer. It is going to return an integer value. So just observe, these are four equivalent statements we have written, or the main function headers, where return type is int and the function main is not receiving any argument. So there is a concept in C called as command line arguments. So if you want to give the input at the command prompt, how main function can receive those command line arguments. So for such applications, we'll be specifying two parameters for the main function. So since it is out of the scope of the syllabus, we'll not be discussing command line arguments. Okay. So in all the programs, whatever we'll discuss throughout this course, we'll be specifying the parameter as void. That means the function is not receiving any argument. Okay. So within parentheses, we'll specify void. If you don't want to specify void, just open close common parenthesis. That indicates the function, that particular function is not receiving any argument. Okay. So if you are using any of these forms of main function header, then you have to give return zero instruction as the last statement in the main function. So if you specify some return type for a function, see that that function is returning that value to the, that type of value to the calling function. Okay. So since I have given the return type as int, return 0 is it should be written as the last instruction in the main function. So there are other forms of main function. You can give it as, say, void main of void. That means if you don't want to return value to the operating system, you can simply give void main of void, or you can give void main open close common parenthesis. So just observe, since the return type is given as void, okay, by default it is integer. If we are giving it as void type, that means the main function is not returning any value to the operating system. So in that case, return zero instruction need not be written. You need not specify return zero statement at the end of the main function. Right? No need of return zero statement if you are using any of these two forms. Okay? These are different forms, totally 6 different forms I have shown to write the main function header. Normally we'll go for the first form, int main open close common parenthesis. So this is the common convention we use for writing any main function. A few references, if you see, they may use int main of void. Okay. Uh, this is what the different conventions you can use for writing the main function header. First four headers, if you are using any of these four, see that return zero statement is given as the last instruction in the main function. So the main function has to return an integer value to the operating system. If you are giving any of these two forms, last two forms, what you are seeing on the slide, in that case, you need not write return zero statement in the main function. Okay, the function, since it is not returning any value, then you need not give return instruction. So this is about the main function header. Okay, and what is the common convention we follow? It is the first one. So this is the function header. Normally we write return type is int, name of the function is main, open close parenthesis, and the last instruction will be return 0 semicolon. Okay. So this is about main functions. Hope this is clear with respect to the main function. The points what we have discussed with respect to main function. I hope you have understood, right? It is a mandatory function. It is a starting point of execution. Operating system is going to invoke the main function. You need to write each letter in that word main. It is a predefined identifier. It must be in lowercase. To indicate it as a function, open close common parenthesis must be given. Right? If you don't specify the return type, it is treated as integer type. And different forms of main functions we have seen. If you are specifying the return type as int, the last statement in the main must be return 0. Return 0, it is one of the instructions. Actually, return is a keyword. So return space 0 if you give. Once that instruction is executed, it is going to terminate the program, and the status code 0 what you are giving in the return instruction, that status code will be returned to the operating system, indicating successful termination of the program. These are the points you need to remember. If you don't specify the return type, that means if you don't want the main function to return the value, any integer value, you can give the return type of the function as void. Void is also one of the keyword in C. That indicates the function is not returning any value to the calling function. So you can skip return 0 statement at the last, okay, at the end of the main function. So this is about main function section. So we are left with the last section, that is subprogram section. So subprogram section we'll use when we go for multi-function program. In addition to main, if you want to write other user-defined functions, in that case we'll go for this subprogram section. So if it were to be simple problem to be implemented, say sum of two numbers if you want to compute, it is just a simple problem which you can implement within just the main function. If it were to be a complex program, or some complex problem need to be solved, then you can divide instead of writing or implementing entire code within the main function itself, which doesn't improve the readability, as well as it whenever any error occurs, it may be any logical error. Okay, in that case, debugging such errors will be difficult. So what we can do is we can just divide the task into subtasks, and for each of the subtasks we can create separate functions, and we can make use of those functions to perform the operations. So this helps in testing, debugging, and maintaining the program easy. So this is the advantage of going for subprogram. Okay, so we can just test, debug, and maintain the program easily. That is one point. And uh, say one more advantage of subprogram is that is code reusability. If same piece of code is required at different points in the program, then what we can do is instead of writing the same code again and again at different points in the program, we can just define it as a function. We can keep it as a function as a module, and at any point of time if we require that code, we can just make a call to that code, so that the control gets transferred to that code and it executes the statement, and control comes back and it resumes the execution of the calling function. So this is the advantage of using the subprogram or user-defined functions. Code reusability. So if redundant code is there in your program, just write it once, and at different points, any number of times you want that piece of code, you can just make a call to that code. So how actually we can handle this through C program, that we'll be discussing once we go to the user-defined functions uh, topic. But since we are discussing subprogram section, to make you understand what actually we are writing in this subprogram section, I have taken one simple example that we'll see in this slide. See, subprogram section, it contains all the user-defined functions that are usually placed after the main function. It is no compulsion that you have to place the subprograms or the user-defined functions at the end or after the main function. You can give it before the main function also. Okay, what is the difference you're finding defining the user defined functions before and after main is, if you are giving the functions after the main, then you have to indicate to the compiler what is the name of the function, how many arguments that function is going to receive, and what type of value that function is going to return. So all this information you have to provide to the compiler through declaration statement. So if Any user defined function is written after main. So see that we are having the function declaration. As you declare any variable before its usage, you need to also declare the functions to indicate to the compiler about the name of the function, number of arguments received by the function, type of arguments, and return type of the function. So all these informations are provided to the compiler through declaration statement. But if we are defining the functions, user defined functions before the main, okay, in that case, no need of specifying any function declaration statements. You can skip the function declaration statements. So already the function is defined, and within the main function, you will be calling those functions. It will not be a problem. Already the function is defined and it is available. If you are going for defining function after main, then only function declaration is compulsory. You need to declare the functions. Okay. So this is one more point you need to remember. I have taken one simple example. Hash include stdio.h arguments, since I'll be using IO statements, input output statements, which are declared in stdio.h, that is standard input output header file. Then main function header. See what form of main function header I've used. Return type I've given it as int. It is a keyword, space, name of the function is main, open close common parenthesis to indicate it as a function. And we have opened flower brace. And since I am giving the user defined function after the main, I need to declare the function. See how to declare the function. I am going to define a print function to print the value of an integer. See what is the return type? Return type of the function is void. I have given name of the function. This is user defined function name. Any name you want to give to the function, you can give. I have given the function name as print. And observe, this print function is going to receive only one argument, which is of integer type. So you can need to specify only the data type. What type of value the print function is receiving and what type of value the print function is going to return. Okay. This is what the information you are providing to the compiler through this function declaration statement. So void print of int semicolon. Since it is a declaration statement, we have terminated it with semicolon. And see, we have given the name of the function, the number of arguments received by print function, the data type we have passed here, and the return type of the function we have given it as void. So how to explain this declaration statement? See, function name is print. It receives one argument of integer type, and this print function is not going to return any value to the calling function. So this is how you can explain this declaration statement. Just observe, in the declaration section, not only the function declaration you are seeing, you are also seeing the variable declaration int a equals 50. You know the meaning of the statement. A is an integer variable which is assigned with the value 50. And now we have made a call to the print function. So first statement within main is the declaration of the function or function prototype statement we say. You can either tell it as function prototyping or function declaration. And next statement is variable declaration statement. Next, the third statement within the main, it is called as the function call statement. I want to call print function to print the value of a. So what I am passing within common parenthesis, it is a. A is a variable which is having the value 50. So once this function call statement is executed, control will be transferred to the user defined function print, where whatever the statements you write within that print function will be executed. After completion of execution of that print function, control will be written back to the calling function. So who is going to call print function? You can see in this example, it is the main. Main is a function which is calling print function. So here in this example, main becomes the calling function and print becomes the called function. Which is the function being called? It is print. Who has called it? It is main. Okay. So main becomes the calling function and print becomes the called function. So once the print function is called, control gets transferred. So what statement I've written, we'll see. And after the control comes back from the print function, so it resumes the execution in the with the next statement in the main function. So that is return 0 will be executed, and we have given closing flower brace. See, this is the main function we have given. Coming to the subprogram section, that is the user defined function after main we have given. See, Return type of the function is void. The same syntax. Whatever you are seeing in the declaration of the function, it's the same syntax we have used. Return type is void, name of the function is print. Within common parenthesis, we have specified the data type as in space ye. Okay. In the declaration, you need not specify any variables. If you just mention what type of value the function is receiving, that is sufficient. But when you go for defining the function, when you are going for implementing the function, you need to specify the name of the variable. So here A is called as the parameter or argument. So whatever you give within common parenthesis for a function, that is called as argument or a that is, sorry, parameter. Argument or parameter. So here A is called as a parameter. Okay. See, once we are trying to define this print function, since it is a function, we need to indicate the block. We have used pair of flower brace, and only one statement I have written within the print function. It is printf. Printf a equals percentage d comma a. Already we have seen an example program to print the value of a. Only one function I had written, that is the main function, where I had declared an integer variable a, I had assigned the value of 50 and I had printed using printf. So same operation I am performing using subprogram. So to perform print operation, I have defined a separate function, that is print. Okay, that is the print function. And within print function, see, this is the only statement I'm having. So this is an example for multi-function program. In addition to the main function, you are also having user-defined function print. The main is called as the calling function, print is called as the called function. Since main is calling print. See, once print A is executed, what happens is control gets transferred to the user-defined function. So then it executes a value, whatever we are passing. A is having the value 50. 50 gets received in this variable, which is called as the argument or the parameter. To this A, the value will be received. And we are printing. Say printf A equals 50. That will be the output, what you'll get. After printing, after printf statement is executed, no, there are no other statements in the user-defined function. So control gets transferred back to the calling function, that is to the next statement after the function call. So return 0 will be executed, which terminates the program and returns the status code 0 to the operating system. So control will be returned to the operating system. So this is how user-defined function works. So whenever you want to implement an user-defined function in your program, you need to have these three basic elements of user-defined function. That is the function declaration statement. The first statement within name, it is called as the function declaration. Function call, print of a. This is called as the function call or function invocation statement, okay, which transfers the control to the called function. So without function call statement, you cannot transfer. Even though you have written main function and user defined function, if you are not having the function call statement, print of a, control cannot be transferred to the user defined function. So this is how two functions can communicate. Okay. So control from one function to other function we can transfer only through function call statement. So what are the different ways of calling a function? Okay, all those things in detail we'll be discussing. This is just an example program I've considered to print the value of an integer. Okay. So once this call is made, control will be transferred to the user-defined function. So what are the three elements you need to have whenever you are implementing any user-defined function? Function declaration, function call, and function definition. See, we have written the code for that function. So this is the user-defined function. If only definition is there without function call, your program will not work. If you are simply having the function call without defining that function, no, then also your code will not work. Okay, so see that all these three elements of user defined functions are there whenever you want to implement your program with user defined functions. Okay, and this is programmer defined or user defined, since user is going to code this function. So this is the difference you're finding between built-in function and user-defined function. The printf is a built-in function which is already coded, compiled, and readily available in the stdio.h C library. We will be simply making a call to the printf function to print the value of the variable onto the screen. So printf is an example for built-in function or library function. So here in our example, print is a user-defined function which user or the programmer has implemented. Okay, this is about the subprogram section. Okay, hope this is clear. Moving on to before winding up, I wanted to show you one more diagram. See how actually the linking takes place. So with this simple slide, I think you can understand. So assume you have written a program. This is just a template I have given. Remember, once the compilation takes place, everything will be in binary form. So we shall not go through that binary form. Just or just have the knowledge about the linking here, compilation and linking. Say, assume you have written a program with say hash include stdio.h header file, and this is the main function you have written. Within the main function, assume you have invoked scanf and printf functions. You have written scanf and printf function, and finally you have given return 0 semicolon. So once this program is compiled and executed, what happens is this is your code, whatever the main function you have written, and once hash include stdio.h. So preprocessor, what it will do is all the declarations what you find in the stdio.h, those declarations will be added to your program. Okay, so it inserts those code to your program, and linker what it will do is after compilation, a linker what it will do is the actual definition. So these are the functions you are using in your program, scanf and printf. So whatever the compiled code or the object code of these functions you are having, that will be added to your binary code. So expanded code will be you will be getting. Okay, that executable code will be finally loaded to the main memory, and now your program is ready for execution. So this is what the operation performed by the linker. So it just adds the definition of the built-in functions, which are the compiled code. Okay, so that will be added to your binary code, and you'll get the expanded code or executable code that will be finally loaded to the main memory for execution. Okay, so this one more point you can go through. Okay, so two more topics I'll discuss, and then we can go for tutorials. Input output operations in C. I've already used printf and scanf functions in the example programs what we have discussed. At this point, we shall just have a small explanation on scanf, the syntax used, and few examples at this time. Since we'll be frequently using printf and scanf functions for all the programs of whatever you're going to implement. Okay, how actually these IO functions are classified, and what are the different functions supported in C. All those details we'll be discussing at the later stage in this unit. At this point, what we'll discuss is what is the function you are using to perform input operation, and what is the syntax of using it, and few examples. So with respect to output operation also, we'll do the same. Okay. See, formatted input function, example is scanf. Scanf is the name of the function. It is a formatted input function. What is the purpose of scanf? It is used to read the data through the standard input device, that is keyboard. So during execution time, if you want to read some values through the keyboard, then you have to make use of scanf function. Okay, it is a user. It is a built-in function of library function. User or the programmer need not write the code to perform the input operation. Just make a call to the scanf function. Okay. See, this is the syntax of writing scanf. Scanf within this is the name of the function within common parenthesis. Since it is a function, we need to use common parenthesis. Within double quote, we'll specify control string, comma address list. Okay. So control string indicates the type of value you are reading through the keyboard. So what type of value you are reading, whether you are reading an integer value or floating point value or character data you are reading, depending on what type of value you want to read. So we are going to give list of format specifier within this pair of double quotes. So this is the first argument we are going to give for scan. So within common parentheses, whatever you give, they are called as arguments or parameters. Whether it is the main function or it may be built-in function or any other user-defined function, within pair of parentheses, whatever you give, they are called as arguments or parameters. Okay. So here, the first argument in the scanf will be the control string, which contains list of format specifier, which indicates what type of value you are reading through the keyboard. Then After that, you are going to give comma, and you will be specifying the address list. So at which address the data you are reading through the keyboard is to be stored. So you will be making use of address of operator, okay, ampersand symbol. For we will be prefixing that ampersand symbol to the variable name. Okay, that is what you are going to give in the address list. So if only one value you are reading, which is to be stored in a single variable, then you'll be using single variable in the address list. If multiple values are to be read, then each variable will be separating it with the delimiter comma. Okay, just see the examples, you'll understand. Int num scanf percentage d comma address of num I have given. See what is the what actually we have written in the control string part. It is percentage d. Here percentage is actually called as the conversion character, but d is called as the data type character. It is an integer data we are reading, decimal integer. That's why d indicates it is the data type character. So within double quotes we have given the format together it is called as format specifier, and format specifier starts with the symbol percentage. Okay, it is called as the conversion character. So once percentage is encountered, compiler will come to know that some data is to be read or written, okay, depending on which function this format specifier is used. Okay, if it is used in scanf, it comes to know that it is the type of value we are reading. If it is written in the printer, type of value we are printing onto the screen. That is what the indication given by this format specifier. Remember, it starts with percentage. Followed by that, we'll be giving the data type character. For integer, decimal integer, we'll give D. For floating point, we'll give F. For character, we'll give C, etc. Okay. One more example, float X, and you can see scanf percentage F, comma address of X. You see, X is a floating point variable we have declared, and you can observe the scanf function call. This is a function called scanf. Within parentheses, you have given percentage f comma address of x. See ampersand. So this is called as address of operator. Whatever that data you are reading during execution time, if you're reading an integer data, that data is stored in the integer variable here. In the variable list or in the address list, you are seeing that variable. Okay, since only one value the function is reading, we have given only one variable in the address list. If multiple values you are reading, then multiple variables will be given, each separated by comma. Okay, see char ch scanf percentage c comma address of ch. So if you want to read all these three values using single scanf, that is also fine. What you have to give is scanf percentage d, percentage f, percentage c. Each of these you need to give within pair of double quote. Okay, and then you can give the address list: address of num, comma address of x, comma address of ch. It's left to you whether you want to read the values through separate scanf functions or all can be read into a single scanf statement. It's left to your implementation. Okay, this is about formatted input function. Coming to the formatted output function, it is printf. Printf, what is the purpose? It is used to print the data onto the standard output device, that is the monitor screen. This is the syntax of calling printf function. It is again a built-in or library function. If you are using printf scanf in your program, you have to include the header file stdio.h. It stands for standard input output header file. Okay. Just see the syntax for printf. Name of the function is printf. Within parentheses, you will specify the arguments. First argument will be the control string again. Within double quote, you will be giving a comma. After double quote is closed, we are putting comma and we'll specify the variable list. So control string indicates what type of value you are printing onto the screen, and variable list indicates or it holds the value which is to be printed onto the screen. So this is the list of variables you are going to give, which will be holding the value which are to be printed onto the screen. Okay, just see the syntax. So C is strictly syntax based or syntax oriented programming language. You need to follow the syntax. You have to give the function name, common parenthesis is required since it is a function. Within double quote only, you have to give the control string. After double quote, you have to give comma, then you have to give the variables. So you need to practice the syntax of the programming language. So given it any problem, if you are aware of the syntax, then you can easily implement the statements. Again, whatever you give within parentheses, it is called as arguments or parameters. As I'm stressing, whether it is built-in function or user-defined function or the main function, within parentheses, whatever you specify, they are called as arguments or parameters. Okay. Few examples: int num equals 20 is the variable declaration and initialization statement I've given. Num is an integer variable which is having the value 20. I'm trying to print that value. See, printf value equals percentage d comma num. Once the statement is executed, what you'll see on the output screen is value equals the sequence of, once double quote is encountered, compiler will come to know that some string is to be printed. It prints the sequence of characters VALUE space equals space, and once percentage is encountered, it comes to know that some data is to be printed. It takes the value from the variable list. Okay, so that is from num, whatever the value held, that will be taken, that will be printed at this point. Percentage d will be replaced with the value 20. The final output what we'll see on the screen is value equals 20, and once closing double quote is encountered, that stops the printing process. It indicates end of the printing. So double quote indicates start, and closing double quote indicates end of the printing operation. So the output will be value equals 20. Coming to one more example, float x equals 3.5. The printf x equals percentage f comma x. See, we are not giving address list. Whenever you are accessing the data stored in a variable, with that is maybe to perform the read operation or the write operation, you need not specify ampersand. Only when you are reading during execution time value for a variable, then only address of operator will be using for the variable. Remember, don't miss that address of operator. Compiler will not raise any error. Okay, if you miss address of operator, but whatever the value you are reading through the keyboard, it will not be stored at that address. So that is the problem. So see that in scanf you will not miss address of operator, and in printf you will not give address of operator for the variables in the variable list. Okay. One more example, char ch equals a, character constant will represent within a pair of single quotes. Ch is a character variable which is assigned with the character a. We want to print a onto the screen. How to print it? You can use printf. Printf within double quote I've used ch equals percentage c. The format specifier we have used is percentage c. So close the double quote, put comma, in which variable the a value is stored, it is ch. In the variable list, you are going to give the variable ch. So just observe these three examples what I have given. Num, x, ch, they are called as variables. The data type we have used for declaring these variables are int, float, and char respectively. And the values what we have assigned, these are constants what we say. Constant value which we have assigned to these variables are 20, 3.5, and a character constant which is represented with a pair of single quote. So these are the constants we have assigned to the variables. And see what are the format specifiers we have used to print these values. Percentage d for decimal integer, percentage f for floating point, and percentage c for character data. So whether you want to read or print, these are the format specifiers you use for reading integer, floating point, and character data. Okay. So this is about printf and scanf functions. Hope whatever we have discussed in today's class is clear.